Hello guys, we got our question number 9 and which is given in symbolic form. So auxiliary equation equal to coefficient of y this much equal to 0. So on solving we got the value of d which is in imaginary form. So we got alpha and beta value and we got our CF like this. Then our measure point is for pi. So pi equal to right hand side divided by a function of d, that is function of x divided by function of d, and our function of x is cot ax. So it becomes cot ax divided by function of d, that is d square plus a square, which is from auxiliary equation. But we know this must be in factorized form, so we introduced minus I here so that we can get this our factorized form. Then after we will apply here partial concept. Then after we solve the integration with the help of Euler theorem. From partial fraction concept, we got this much value into function of ax, where we'll send cot ax to both of the term so that this is going to be one term, this is going to be another term, and here the same process. First we have to get the value of this, then after this, then we will substitute that value in pi, that is equation A. So we are going to repeat our same process as we have done in our earlier video. First, here we are going to consider this much term only. Later on, we will consider this coefficient. So from equation A, we are going to solve the value of this one, 1 by d minus ai into cot A x. So the term is here, and we are going to apply this formula so that it took this form where m is ai. So it become e to the power aix integration e to the power minus aix cot ax into dx. Means here we are going to return the value of e to the power minus iax from the Euler theorem, which can be written like this: cos ax minus, here is minus, so here is also minus I sin ax, and the cot term is changed into cos and sin term. So on multiplying to each, the new expression is going to be like this. Means here cos and cos going to be cos square divided by sin ax, and here sin and sin going to be cancelled, just only cos term will left over there. Then after we know there is no integration for sin square or cos square, so we'll change this cos square in the term of sin square so that the denominator sin ax will cancel the square term and it will be in linear form. So after converting into sin square, we're going to separate the denominator to each of them. So 1 by sin ax is going to be cos ax, and sin a square ax divided by sin ax is going to be sin ax, and this is as usual copied here, and this is just appearing like as multiplied form. So on doing so, now they all are in linear, so we can write their integration value, which can be seen like this: integration of cosec ax is equal to log cosec ax minus cot ax divided by coefficient of a. Similarly, integration of sin ax is minus cos ax divided by a. In the same way, integration of cos ax is sin ax divided by a. Then after we will gather our sin and cos term at one place so that we can return them to Euler form again. So this is our cos ax and sin ax. So this is going to be our Euler formula like this, and this value is going to be copied from top to down. Then after we will send this e to the power iax to inside so that it will multiply with this term also and to this term also, and here it will come and e will be multiplied form, so power are going to be added, thus the power is going to be 0, so e to the power 0 is 1. Hence our final expression is like this: 1 by a bracket e to the power iax log bracket cosec ax minus cot ax plus 1. So this was the value of 1 by d minus ai cot ax, which is this one. Means the value of d minus ai cot ax was calculated out to here. So we need also the another term, that is d plus ai. So we'll just replace I by minus I. So we're going to get this form. Means wherever there is I, there will be minus I. So we got our the value of 1 by d plus ai cot ax. So we got the value 1 and 2 both for our equation A. So from our equation A, we can see that the expression was like this. So on returning the value of 1 by d minus ai cot ax and 1 by d plus ai cot ax, we got our expression like this. This box value is cosec ax minus cot ax, which is same in both terms. So we return their value and we got our expression looking like this, from where our 1 and 1 term is cancelled and we took log common from both terms. So the remaining term is going to be like this, and log, and this our bracket value. Then after we'll return the value of again Euler theorem, that is e to the power iax will be cos ax plus I sin ax, and e to the power minus iax will be cos ax minus sin ax, and there is minus, due to which the negative sin ax is going to be positive and cos positive going to be negative. So cos and cos of this term going to be cancelled. As a result, we are going to get 2i sin ax. You can do it roughly, and the left term is this log, and this bracket value was cosec ax minus cot ax, and this is the coefficient which is coming multiplied. So 2 and 2 is cancelled from here, and the left expression is our pi. So our pi and cf are known. So complete solution equal to cf plus pi.